Hello everyone, you are welcome in this session. As you know that we have already completed our syllabus, so here we are going to review the last topic that we have discussed in our last class, that is integration. So we will here discuss about the basic parts of integration. So those who were present in the last class, you know we have discussed the main objectives of this topic and we have solved some problems. So I have provided you one problem set, so you can have a look on these problems, and there are some similar problems you can have a look from this book from chapter 5.6. so today we will try to solve these problems and we'll try to get the idea again of integration. So let's start. So you know that integral calculus or integration has two parts, that is indefinite integral and definite integral. So in indefinite integral you will get to see this type of forms: integration of f of x dx. So we are actually integrating this function f of x. Here there is no lower bound of integration, upper bound of integration. There is no lower bound and upper bound. So this is about indefinite integral. What is definite integral? You will have the same notation: integration of f of x with respect to x, but this time there is lower bound a, upper bound b. So here a and b are the values for x. X equals a, x equals b, but you don't need to write x equals, you can skip this. But the thing is, these are the values for x. X equals a, x equals b. So definite integral or integration from a to b of f of x with respect to x, this part is actually denoting area problem. So in our last class we have discussed this. So you can understand the difference between this and this. Here there is no lower bound of integration, upper bound of integration, but here we have finite interval, that is from a to b the function is continuous. The function is going to be integrated with respect to x from a to b. So that is the thing that you know. So besides this we have some properties also. The first property is integration of any constant with respect to x. So you are integrating a constant. Here c is a constant, that is any number, 1 2 3 minus 1 minus 2 minus 300, like this. So if we have to integrate a constant, then it is actually c x. The result of the integration will be this one, c times x. Suppose you have, let's say, integration of 3 dx. So it is actually 3x. Integration of minus 4 dx. So we are integrating minus 4. Minus 4 is a constant. The result will be minus 4x. So here instead of x it may be other variable. You can have a look on the formula. Here instead of x, all the way you are having u, but no problem, you can also think about x instead of u. So if we have, let's say, minus 5 du, it will be minus 5 u. That means the variable that you have, that will come here. The variable that we have here, that will be here. Let's say we have integration of 100 dt. So the result will be 100 t. That is the constant times the variable. Constant times the main variable. So that is what we know as the first property, that is we are integrating a constant function. Okay, so this is how we can write all the properties here. So this is the first property, that integration of a constant is constant times the variable. Similarly, we have the second property, that is if we have constant with f of x, that is constant times a function, then this constant can be pulled out before the integral. So have a look, this constant has been pulled out here. So this is about the second property. Suppose we have 4 x squared. We are integrating this. So this 4 is a constant that can be pulled out. And now we have to integrate this, and that will go with the formula. You have to check which formula will be applied here, but our main target is to learn the property. So the property says that if you have a constant, then the constant will be pulled out. So this is the second property. The third property is the summation property. Suppose you are integrating a sum, that is f of x plus g of x is here. So integration of a sum is actually the sum of the integration. That means we can write separately integration of f of x plus integration of g of x. For example, suppose you have integration of x squared sine x, and we are integrating with respect to x. So what you can write, you can write separately, that is integration of x squared plus integration of sine x. And now you have to find the answer using the formula. You have to write the answer here using the formula. So that is about the sum property. Similarly, we have another property here, integration of difference or subtraction property, that is the same. Instead of plus, we have now here minus. So integration of f of x minus integration of g of x. So we can write by this way. Suppose we have sine x minus cosine x. So this is our function we are going to integrate. So that means you can write separately. Integration of sine x, there is a minus, and integration of cosine x. So now you have to apply the formulas to get the result of these two integrals. So these are the properties that we have here. Now let us directly solve some problems from this problem set, because you know that this is just a review class. So already we have discussed what is integral calculus and how we can solve some problems using the formulas and substitution process. So here you can see there are some problems that are going with the basic properties, and below we have some problems that are going with substitution property. So we will try to solve some of the problems and try to review. So one thing I need to mention again here, that is we have one indefinite integral, or we may have one definite integral, let's say. So what is the difference? The difference is, in indefinite integral there is no lower bound and upper bound of integration, but in definite integral there is lower bound of integration, upper bound of the integral. So if we have only the indefinite integral, there is no lower bound and upper bound, so in that case you have to just use the property, you have to just use the formulas, and you can find a result. The result of the integration is known as antiderivative or antiderivative. So if you have an indefinite integral, you can easily find the antiderivative using the properties or formulas. But if you have a definite integral, first you have to find the result of the corresponding indefinite integral, skipping a and b. Suppose this is our definite integral, but we have to at first find the result for the corresponding indefinite integral. Then you can think about the result for the definite integral. So how we can find the result of the indefinite integral? Indefinite integral can be found by the property or the formulas, but definite integral can be found after having the antiderivative, and the result can be found by one important theorem that is known as fundamental theorem of calculus. Fundamental theorem of calculus is actually dealing with the definite integral. So suppose we have a definite integral, integration of f of x with respect to x. Here we are integrating with respect to x, but I am writing here dx. dx is the small amount, so this is actually with respect to x, it is the meaning. So however, here suppose we have lower bound and upper bound. So what we have to do? At first we have to find the result of this indefinite integral. Suppose the result of the indefinite integral is capital F of x. Here capital F of x is the result of the integration or antiderivative. Antiderivative means result of the integral or the answer of the integral. So small f of x and capital F of x are different. You can see this is small f of x and this is capital F of x. So these are two different functions. So by applying the property or formulas, or let's say substitution process, somehow you have found the antiderivative of the indefinite integral. Now since you have the lower bound and upper bound of the integral, what you have to do? You have to also think about the upper bound and lower bound. So with the antiderivative we are mentioning that upper bound is b, lower bound is a, and we are writing by this square bracket. So the result will be just a value, because you know that definite integral is nothing but area. So area will be a finite value. So what you have to do? Fundamental theorem of calculus says that if you are integrating a continuous function f of x from x equals a to x equals b, then the antiderivative is capital F of x. So the result of this definite integral will be antiderivative at upper limit minus antiderivative at lower limit. So antiderivative at upper limit minus antiderivative at lower limit, that is actually the area. That will give you a finite result. So what we have done here, once you have the antiderivative, then in the place of x we are plugging just upper limit and lower limit, or upper bound or lower bound. So you know that x equals a and x equals b. So in the place of x we are plugging at first b, then in the place of x we are plugging a. So this is about fundamental theorem of calculus. Now we are ready to solve some problems directly from this problem set. So suppose, let us work with some easy problem at first. So let's say we are solving this one. So we have to integrate x to the 4 plus x. So this is our function. If we consider the main notation of integral calculus, then we have an integral sign, we have the main function, and we are integrating with respect to x. So first of all, you can see that this is an indefinite integral. There is no lower bound and upper bound of integration. So this is easy to solve by using the formulas, by using the basic properties of integration. Okay, you know that there is a sum property here. Integration of sum or subtraction can be written by this way. We can write separately. So here we have integration of x to the 4 plus x. So we can write integration of x to the 4 plus integration of x. Now you have to look at the formulas. So this is our first formula. You can see, if integration of u power n du, then we can write u power n plus 1 divided by n plus 1. So this formula is not valid for n equals minus 1, but for other values of n that is valid. So here we have a formula for u variable, but we can think about integration of x power n, that can be written as x power n plus 1 divided by n plus 1 similarly. So you can have a look here, that is all the way whatever formulas we have, all formulas are based on indefinite integral. There is no lower bound and upper bound of integration. So these formulas are also applicable for definite integrals. Okay, so formulas are same for both indefinite and definite. But one thing is that if you have an indefinite integral, then you can add a constant finally with the antiderivative. So plus c plus c plus c, you can see that a constant is added. But if you want, you can skip. There is a big history why we can write plus c, but that is out of the scope here. We are just solving the problems. So we have integration of x to the 4. So it is going with this formula, integration of x to the n dx, that is x power n plus 1 over n plus 1. So here we can write x to the 4, its integral will be x power 4 plus 1 over 4 plus 1. Similarly, this one here, actually we have x power 1, so it can be written as x power 1 plus 1 over 1 plus 1. So the result is x power 5 over 5 plus x power 2 over 2. So this is our final result of this integral, and this result is known as the antiderivative, capital F of x. This function is the small f of x, but the result that you have found, that is the antiderivative. That means the answer of the integration. Actually, integration and differentiation are opposite operations, so that's why integration is also known as antiderivative. Whenever we have discussed integral in our last class, I have mentioned all these things. So the result that you have found, that is the antiderivative or answer of this integration. So since this is an indefinite integral is given, there is no lower bound and upper bound, so that's why if you want, you can write a constant plus c with the final result. Okay, but if you want, you can for now skip this. Okay, so that is about a very preliminary problem. So let us now think about other problems. So this time we are going to solve a similar problem. This time we will solve a definite integral. Let's take this one. So we have a definite integral here. Definite integral means here we have a lower limit of integration and also upper limit or upper bound of integration. So this is the lower bound, this is the upper bound, and this is our function. So whenever we have this type of definite integral, first of all, to solve this you have to consider its corresponding indefinite integral. So the corresponding indefinite integral is this: e to the x minus x to the minus 7 plus 3. So we are integrating with respect to x. So we are ignoring the lower and upper bound for now, and at first we will solve this indefinite integral and we will try to find the antiderivative of this. So if we have a definite integral can be solved by the fundamental theorem of calculus, that is integration of f of x from a to b can be solved by this way. Once you have the antiderivative capital F of x, then antiderivative at upper limit minus antiderivative at lower limit. Where you have x, input the upper limit b and lower limit a. So that is about fundamental theorem of calculus. So before solving this definite integral, we will solve its indefinite integral. So let us solve the indefinite integral first. So this is going with the property. We can separate the sum and subtraction terms. So integration of e power x minus integration of x power minus 7 plus integration of constant 3. Now you know the formulas. What is e power x? Integration of e power x is same e power x. So let me write the formulas here that will be applied. Integration of e power x, that will be e power x. Here x to the minus 7, this is going with this formula x power n. Integration of x power n, that is x power n plus 1 divided by n plus 1. This formula is not valid for n equals minus 1. So for other values of n can be any real number, then we can apply this. So integration of x to the n is x to the n plus 1 divided by n plus 1. Now we will try to apply these formulas. So here integration of e power x, that is going with this formula e power x. Integration of x to the minus 7, this is going with this formula x to the minus 7 plus 1 divided by minus 7 plus 1. Integration of 3, you can remember that there is a formula integration of a constant with respect to x, that is constant times that variable x. So here integration of 3, that will be 3, and we are integrating with respect to x, so there is x. So integration of 3 is 3x. So this is the result of the integral, that is e power x minus x to the minus 6 divided by minus 6 plus 3x. If we try to simplify again, we can write by this way: minus minus plus 1 over 6 x to the 6 plus 3x. So this is the result for this integral, or this is the antiderivative of this integral. Okay, so here we have found the result of the integration, that is this. It is known as antiderivative. So don't forget that we have to deal with the lower bound and upper bound. We have to find the area of this. That means we have to deal with this definite integral. So the definite integral with the bounds 1 to pi. So let us now give here 1 to pi. So integration from 1 to pi of this function is this one, but here according to fundamental theorem of calculus it will be pi, it will be 1. So now have a look on the fundamental theorem of calculus, that is, if f of x is continuous over a to b, then if you have the antiderivative capital F of x, so the area or the definite integral will be capital F of b minus capital F of a, where you have x input b and a. That is the thing. So our antiderivative is this one. So the result will be antiderivative at upper limit minus antiderivative at lower limit. So let me write here correctly. Antiderivative at upper limit, where you have x, you need to input the upper limit pi. So e to the pi, pi to the 6, 3 times pi. So antiderivative at upper limit. We are writing the same function here, but we are changing the x. X is with upper limit pi. Similarly, antiderivative with lower limit. So where you have x, locate that positions first and then input the lower limit. So this is our final result. Once fundamental theorem of calculus is done, then you can use your calculator to get the result of this, and then subtract this and this. You will get the final result. That will be the area. But let me simplify here again. So here you will get e power pi plus 1 over 6 pi to the 6 plus 3 pi minus e power 1 is e plus 1 over 6, and 1 to the 6 is just 1, so just here I am writing 6 plus 3. Now you can use your calculator. So this is our result. So this is about fundamental theorem of calculus, which is applied in definite integral. So whenever you are solving a definite integral like this, at first consider its corresponding indefinite integral. Forget about the lower and upper bounds. Use properties and formulas. Then you will get the antiderivative. Once you have the antiderivative, then apply the fundamental theorem of calculus, antiderivative at upper limit minus antiderivative at lower limit. This is your final result. We can solve another problem here. Let's say this one. So this time we have sine x plus cosine x minus tan x. This is our function. So what we can do, at first have a look. This is a definite integral. We have lower bound, upper bound. So forget about this lower bound and upper bound. First of all, think about the corresponding indefinite integral, sine x plus cosine x minus tan x. So we can now solve this indefinite integral by using the properties and the formulas. So first of all, we can separate. Now use the formulas. So integration of sine x, have a look. Integration of sine x is minus cosine x. Integration of cosine x is sine x. What about integration of tan x? So integration of tan x is minus log cosine x. So let me write the formulas here. Integration of sine x, that is minus cosine x. Integration of cosine x, that is sine x. And integration of tan x, that is minus log cosine x. So here we are using modulus sign because whenever you are going with log function, then absolute value will come. Have a look, all the way wherever you have logarithm, you can use absolute value. So our result will be integration of sine x is minus cosine x. Integration of cosine x is sine x. Just we are applying the formula. Integration of tan x is minus log cosine x. So the result is cosine x plus sine x plus log absolute value of cosine x. This is our antiderivative. That means the indefinite integral has been solved. So now we can think about the lower bound and upper bound. So lower bound of integration is x equals pi by 2 and upper bound is x equals pi. So here we have pi by 2 and pi. So according to the fundamental theorem of calculus, what we can write, this is our antiderivative. So in the place of x, you have to input upper limit first, then use minus, then in the place of x input lower limit. You will get the final result of the integration. So first of all, let us use antiderivative at upper limit. Antiderivative at upper limit minus antiderivative at lower limit. That is the result for integration of f of x from a to b. So here where we have x, in that places we will input pi. Then there is a minus. So antiderivative at upper limit is done. Now antiderivative at lower limit. So in the places of x, now we will input pi by 2. So now if you use your calculator, from the first part you will get a value, from the second part you will get a value, and by subtraction you will get the final result. So that is the definite integral. So this is how you can solve all the problems here. So these are the basic problems that are going with properties and formulas. So these problems are directly going with the formulas, but somehow there are some other problems where you will not get the result directly. Okay, so you may have to use substitution process, because the function that will be given, that will not go with directly with the formula. So that's why you have to use substitution. So for example, suppose we have this first problem. So now we are going to learn substitution. Although we have discussed this in our last class, I am again reviewing this. So substitution process. integration by substitution. So here, suppose we have this problem. This is a definite integral where we have lower bound pi and upper bound 2 pi. So forget about this definite integral. First of all, we have to solve the corresponding indefinite integral. So here this function is sine 2x plus 4, but if we have a look on the formula integration of sine x, we just have a formula for integration of sine x, that is minus cosine x. But here we have a different function, sine 2x plus 4. So what we have to do? We just know integration of sine x is minus cosine x. But here we have a different thing. So if you get this type of cases, then first of all think about substitution. So substitution process says that if you can convert it to a single variable, any variable can be considered instead of this 2x plus 4, then the calculations will be easier. Suppose here we have x and we are integrating with respect to x, then only this result is possible, that is minus cosine x. So variable doesn't matter. If we have now sine t and we are integrating with respect to t, then we will have minus cosine t. Suppose we have sine u and we are integrating with respect to u, then the result is same, minus cosine u. So you can see variable doesn't matter, x, t, u, whatever, the formula is same. Suppose we have sine z, then we can write minus cosine z, because here the function is for z and we are integrating with respect to z. So the formula is same for any variable. So our target is to write here a single variable. So what we can do? Here we can use substitution. Let us consider that this 2x plus 4 is any variable, let's say u. We are considering here u. So what is the change in the integration? It will be sine u. So instead of 2x plus 4 we are writing u. So we are converting x variable to u variable. Therefore it should be obviously something like du, not dx. So you have to also find the conversion of dx. What will be the result of dx? You need to also find. So dx means you have to differentiate this function, then only you will get dx. So to have dx, we are differentiating here both sides with respect to x. So differentiation of 2x is 2, differentiation of 4 is 0. I am writing directly here because you know differentiation. Now ddx of u, it can be written as du dx. So your target is to find dx. So dx is actually du divided by 2. So have a look, you have found the result for dx. So dx equals du divided by 2. So now this total x variable has been converted to u variable. So it is 1 by 2 sine u du. Now we can easily integrate. It is going with the property you know that at first I have written here some properties. If we have constant times a function, then that constant can be written before the integral. So here we have a constant times a function, so it will be 1 by 2 sine u du. So integration of this will be now according to the formula. Here I have written that integration of sine u with respect to u is minus cosine u. So minus cosine u. So the result of the integration is done, but somehow it is incomplete because your problem is actually with x variable. So you have considered that this 2x plus 4 as u. So let us get back to x part again. So what is u? U is 2x plus 4. So we can write here minus 1 by 2 cosine u, or if you want you can also write cosine here. That is just the representation. Okay, so where you have u, you have to now replace it with 2x plus 4. So our result is actually minus cosine 2x plus 4. So integration of this has the antiderivative, this one. Okay, we have found the result of the integration, but don't forget that we have to solve the definite integral. We have lower bound 0, upper bound 2 pi. So always the pattern is, if you have a definite integral, first you have to solve the indefinite integral. At first try to solve the corresponding indefinite integral, and then once you have the antiderivative or the result of the integration, then think about the fundamental theorem of calculus, that is upper bound and lower bound. So here we have lower bound 0, upper bound 2 pi. So we can now find the area, that is using fundamental theorem of calculus. So where we have x, in that part we will input 2 pi. So antiderivative at upper limit, here our upper limit is 2 pi. And antiderivative at lower limit, so the lower limit is 0. So now you can do some simplification and you will get the result. Okay, so this is up to your calculation, but the main part is this. So let me write one more term here. You will have minus cosine 4 pi plus 4 divided by 2 minus minus plus cosine 0 plus 4, that is cosine 4 divided by 2. So this is our final result, or if you want you can also find the numerical solution. So this is about substitution. Let us solve another similar problem and then we will close the session. Let's solve this one. So we have a definite integral here, integration from minus 2 to 6, and the function is e power minus x minus 4, and we are integrating with respect to x. So this is a definite integral. First of all, think about its indefinite integral, e power minus x minus 4. So we are skipping the lower bound and upper bound. Okay, so there is no direct formula for e power minus x minus 4. We just know about the formula e power x. Integration of e power x is e power x. Have a look. E power u is e power u. So I have mentioned that the variable doesn't matter. If you have e power t and you are integrating with respect to t, then it is e power t. If it is e power z and you are integrating with respect to z, then this is e power z. If you are integrating with respect to u, then the result will be same, e power u. So our target is to convert this part as a single variable u. Then only we can think about the formula, and at the same time dx will be converted to du, something like that, whatever we have done here. Have a look. We have considered a portion as u just to match with the formula, and automatically dx has been converted to du part by differentiation. So let us do the same thing. So here our problem is e power minus x minus 4. We are integrating with respect to x. So first of all, let us consider that minus x minus 4 is u. So what is the change here? Minus x minus 4 is now u. At the same time, we need to convert dx, so that's why we have to differentiate here. So differentiation of minus x is minus 1. Differentiation of minus 4 is 0. I am writing directly here. ddx of u, that is du dx. Your target is to find dx. So minus dx equals du. That means dx equals minus du. So this is dx. So what is dx? Dx is minus du. Now this minus can be pulled out because minus 1 is here. Any constant can be pulled out. So minus integration of e power u with respect to u, and that is going with the formula. The result is minus integration of e power u will be e power u. So the result is in our hand, but just we need to do a simple replace, that is where you have u, just replace with minus x minus 4. So minus e power, let us replace with this. You know that u is minus x minus 4, so minus x minus 4. So that is the result for this integral, e power minus x minus 4. So this is done. Now if we think about the definite integral, lower bound upper bound, minus 2 to 6, it is given that the lower bound of x is minus 2, upper bound of x is 6. So here 6 2 minus, that is the area now. So antiderivative is found, antiderivative at upper limit minus antiderivative at lower limit. This is how we will get the result. So let me write here e power minus, in this part you have to input the upper limit, minus e power minus 2 minus 4. So in the place of x I have just plugged the upper bound and lower bound, nothing else. That is about the fundamental theorem of calculus. So now you can easily write what is the result, that is minus e power minus 10, here minus minus plus e power plus 2 minus 4. You can keep your result here, no problem. So that is about integration. So this is the review of integration, and I am closing the session here. So that's all for today. Thank you. I hope you have understood this session.